So today's agenda, like we'll just start with some very quick intros. We'll spend most of the time after that on the fireside chat. And then towards the end, we'll have about 10 to 15 minutes for like just audience questions as well. So I can introduce myself first. I'm Nihit. I'm currently the CTO and co-founder of Refuel AI, our early stage machine learning infrastructure startup. And I'm also currently working with the amazing team over at CoreEyes on sort of designing and teaching the machine learning ops course. We're doing the first offering of the course starting July, which is sort of what brings us here today. And yeah, prior to Refuel, I've had software/machine learning roles at Facebook and at LinkedIn, and a short stint at Slack, which is how Josh and I first got to know each other when I was first interning on his team well over 6 years ago at this point.
I say back when you were in grad school, exactly. Yeah.
Yes. So Josh is currently an engineer at ViewGrid. It's a startup working on decarbonizing transportation. Prior to ViewGrid, Josh was, as I mentioned, at Slack for many years. Most recently, in terms of his tenure at Slack, he was on the search, learning, and intelligence team, and he likes to call himself a recovering manager. Having most recently built and led Slack's data engineering team, and prior to that, he's built and led teams at companies such as Cloudera and before that at Google. He's a member of the Apache Software Foundation and also a founder of the Apache Crunch project. And a co-author of one of O'Reilly's books on advanced analytics with Spark. And he's gone viral on Twitter a few times, which you can ask him during the audience Q&A.
Once every 10 years, roughly speaking.
I'll take your word. Yes.
Amber called me an influencer. Oh, Amber, that's hateful. Please, I build things. Amber, please.
All right, so let's, so just a quick, just a quick introduction and context setting for the event today. So as I mentioned earlier, I'm helping teach the MLOps course, and sort of the goal for that course really was to help bridge this gap between sort of all the state of the art ML research that's going on, and then also this very pervasive observation that it still remains fairly hard to build, maintain real world machine learning systems, right? It's far from a joyful experience for anyone building / leading teams that's doing this. So what's the gap there? What are some of the learnings from having done this a few times? And yeah, sort of that's the overall goal of the course. We're doing the first offering of the course in July, we're doing it in partnership with CoreEyes. And Amber is here, so you can feel free to ask her questions as well during the Q&A about CoreEyes. But they're an education platform for professionals to build technical high demand skills. And one of the things that's unique about them is it's a fairly interactive model where you have it's a combination of just live in-person or just online synchronous learning with courses and with fireside chats and projects as well. So definitely do check out some of the course offerings as well.
It's great stuff too. It's all built on Gitpod, right? Are y'all using Gitpod for it still?
Yes, I believe so. A lot of the courses do.
Gitpod is just super Gitpod. Cool. Shameless plug for Gitpod. No affiliation with them. It's just super cool. I love that thing.
I have tried it and it's amazing. Yes.
Yeah, it's truly amazing. Yes, exactly.
Anyway. Yeah, cool. We can get started on the fireside chat itself.
Sure.
And thanks folks for joining again. So Josh, I'd love to hear a bit about just your professional journey. I mean, I introduced you a little bit, but just tell us a bit about all the experiences that you've had at a variety of companies of different sizes, different maturities in terms of just building data machine learning teams. Just what led you to this area in the first place, and what keeps you excited today?
Oh yeah, that's a good question. I'm trying to I'm gonna have to time box my answer here, so I'll keep an eye on the clock because I've been doing this for 20 years, and so it's been things have been going on for a while. Um, so I studied math in college. I was a mathematician, but kind of learned enough computer science to be dangerous. And so I think like my first few years out of, and I think like this is like I graduated in like 2001. So maybe it was like machine learning back then was called data mining.
Sure.
And we did a lot more statistics than we did, like sort of like machine learning as is done now.
Yeah.
So my first job was working at IBM, and a lot of the work there was basically I was analyzing. My first job was analyzing like microprocessor test data to figure out like what sort of signals, what data that we collected at the wafer fab stage of making a microprocessor was indicative of like how well a microprocessor would perform during like actual functional testing when we would try to load an operating system on it and stuff like that. And so that was like my first like professional model building experience.
Yeah.
I studied I think because I'm a masochist and glutton for punishment, I decided to do a master's degree at the University of Texas while I was working at IBM. IBM paid for it. And so that sort of through a series of unfortunate events led me to a company called Zilliant that was doing price optimization stuff. So like helping basically big Fortune 500 companies optimize their prices to meet demands and like sort of core economic stuff. And that was enlightening for me insofar it was the place where I learned that really the problem, like the optimization problem or the data problem, was really just like a BI problem, which was to say, literally, these companies literally had no idea how much it cost them to sell things. And so the secret to price optimization was really just like, this is actually how much it costs for you to fulfill this deal.
Yeah.
Like that sort of stuff, right? I worked at Indeed briefly. We built machine learning models for like Indeed salary estimator machine learning model. I worked on that at Indeed.
Right.
Then I kind of eventually got to Google. I got to Google in like 2007, and this was kind of a revelation because this was my first exposure to like big machine learning. And I will never forget being introduced to smartass and sort of like all the crazy mind-bending stuff Google was doing around machine learning to do ad click prediction and obviously lots of other things and stuff like that.
Right.
So I got involved with that stuff for a few years. Did a bunch of different ML-ish kind of things at Google. I was sort of towards the end of my tenure at Google, I was tasked on working in the unfortunate Google Plus, which those of you who are too young to remember maybe will almost certainly be better off for it. But nonetheless, it was an ill-fated social effort. I was pretty unhappy. I was much happier doing sort of data stuff. And so I went to Cloudera because I wanted everybody, and again, this is 2011. This is the beginning of the big data thing. I wanted everybody to be able to work with data the way that Google did across all sorts of different industries. And so that was when I started, I think, talking, to Amber's sort of cruel point about me being an influencer. Like that was sort of when I became an influencer, as I started like, I think I had been fortunate because, I was not a lot of people who had done machine learning at Google were like out in public talking about like how this really big machine learning stuff was done. And I knew, and I talked about it and stuff, and Google didn't, have me killed or sue me or whatever. And so I got to sort of share a lot of stuff.
Maybe like give us an example of just like what was something, what's an example of like something that was done at Google way earlier than like maybe what became standard practice in the public domain?
Yeah, totally. So I don't know that it was done earlier. It was just, I think like a lot of things are done in theory. And then like Google was a place where, at least in the knots, we did stuff for real. And so for instance, like just a weird example, but in search indexing, like in search engine theory, there are document partitioned indexes and there are term partitioned indexes. And people have been talking about doing term partitioned indexes since like the 80s. But Google actually built one, like for real, right?
Yeah.
And it was the same thing, which was fundamentally Google was doing to do ad click prediction. They were doing stochastic gradient descent. That was fundamentally what they were doing. It was so funny. They didn't call it that because the original engineer who designed it was a guy named Eric Veach, who's really famous, did a bunch of different, he invented Google's ad hoc as well. He was a graphics guy. He did his PhD in graphics, and he like basically rederives stochastic gradient descent from first principles based on like doing like, I swear to God, like a Taylor series expansion of the objective function he was trying to optimize.
That's amazing.
Under the constraint basically that like to process like essentially any kind of nonlinear, let me rephrase this, any machine learning model that was not linear in the data was like an absolute non-starter because it took a week for a single data center at Google to process all of the data they had on like ad click prediction stuff. So like,
Right.
you know, if it takes a week, order n is pretty much a fairly hard constraint. Basically, there's no n
Sure.
squared, there's no n
Yeah.
log n, like all unacceptable. um and then it was so fun because they basically like, I love this so much, like they experientially rediscovered regularization, and they came up with their own regularization technique that
Oh,
was, they
okay.
like sort of like ran into the regularization problem where they would like, you'd end up with like a feature that had like too much weight on it basically as an artifact
Right.
the way the data was trained, right? And there was no damping factor in the
Yeah.
original Taylor series expansion. So they like came up with all these like clever hacks like this that just were so delightful and joyful to read. Like
Yeah. Yeah.
um
Absolutely.
stuff like that. Anyway,
Yeah.
sorry. Like I said, I could just
Yeah.
prattle on about this stuff forever. Yeah. Anyway.
For sure. Yeah, that seems like a super kind of talented, amazing group to be
Yeah.
to be part
It
of.
was
And
it was really, really cool. It was super neat
yeah,
stuff. Yeah.
yeah,
Anyway.
awesome. Cool, cool. So maybe like yeah, it's sort of to look at kind of some of the places that you've spent time at more recently, like
Yeah.
Google, Slack, Cloudera. Like when you joined them and during your tenure there, like companies were at very different stages of maturity. Kind of what were yeah, I'm curious to hear about differences, similarities between kind of these companies in terms of just like how do teams internally think about the importance of data, machine learning, and like just the practices associated with building ML applications.
Yeah, I mean, it's a good question. They were all, kind of fairly radically different in that
Yeah,
respect. I think, by the time I got to Google, I mean, I think, you know, you see this with kind of like companies these days. There are like ML companies,
sure,
and then there's kind of everybody else.
sure.
And Google was obviously in many ways like the first ML company,
Mm-hmm.
where like um, doing machine learning was already like a fairly reasonably well established practice by the time I was there. Like the smart ass system that was doing ad prediction launched in 2004. Before that, it was Google just kept ratios basically to estimate the CTR of an ad. It's
Okay,
like they're just like
right.
it worked for like 4 years and it worked pretty
Yeah,
well.
yeah,
At the time, they had tried but had not successfully replaced the core search ranking algorithm with a machine learning model. I think obviously that's been changed now,
right.
but fundamentally it was a data company
Yeah,
like through and through. And if you are a data company kind of through and through, like machine learning is fairly easy in some ways. Like it's a very natural progression. Cloudera was interesting, and I got to sort of expose myself to like a wide variety of companies, some of which were data companies and some of which were not. I always call it like among like sort of classic big companies, Capital One, State Farm, Walmart are all really like generally speaking phenomenal data companies. And so I think for them, they were already at like they already had such sort of care and stewardship around quality and stuff like that. They just took this stuff so seriously
yeah,
that it was relatively easy to introduce them to machine learning, and they could
right,
just do super cool stuff because they had that foundation. For
right,
folks that didn't have that foundation, yeah, it was hard. It was not,
right.
it's a lot of work to kind of put the stuff in place. And it has to anyway. And then Slack was interesting insofar as like there was nothing really when I got there. Like wasn't really anything. And so that was my experience of actually getting to build that data culture, build the infrastructure, build the foundations and all that kind of stuff that grew over time.
Yeah,
Um, which was, that was an experience, I guess. I wouldn't necessarily want to do it again, but it was fun. And like honestly, one of
right.
the reasons I chose WeaveGrid as sort of my climate tech focused company was that it is a data company through and through. Our
Yeah,
whole business is data. We take data very seriously, and that was fundamentally like what I wanted in my next role, something meaningful
yeah.
at a data company. That was sort of what led me here. So yeah.
Awesome. Yeah, yeah. Maybe like so very quickly, like take us through kind of how does Viewport as like a new company. It's a sector that not a lot of kind of folks in the audience might be familiar with. Like just kind of tell us how does Viewport leverage data
We
in the products it builds.
Yeah, we do a bunch of different things. So our sort of job is to help like large utilities manage EVs on the grid. And I can get too nerdy about this stuff, but like the TLDR here is that like if everyone in the country starts driving an electric vehicle over the next decade, which is sort of the hope, the electric grid is not really designed for that to happen in any number of ways. And so utilities are very interested in sort of understanding and eventually managing the EVs that are on the grid. They want to know kind of roughly where they are, when they're charging, like all that kind of stuff, so they can optimize accordingly. So we do a bunch of machine learning around like that problem, from like literally analyzing like meter data from like utilities gather to figure out who has an EV, when did someone sign up for an EV, so that their utility can reach out to them and like get them signed up for a program where the utility can like monitor the charging, understand it, and then eventually like manage it. And then that's a whole sort of interesting optimization problem of like how, given you have all these cars and they need to charge to such certain levels, how do you schedule their charging across an evening or 24-hour period so as to keep kind of the load minimized across the grid to be nice to transformers and substations and all that kind of good stuff. So that's, it's just all data. Like we're the company is like a database with a building around it. That's all.
Fair. So I think like when we this has sort of been my personal experience, but then also I've seen this happen a few times kind of with teams that I've been on. Right, it's whenever like for anyone with like a data or a machine learning background, like when you kind of look at a new business product problem, like this instinct, like it's often very tempting, right, to like kind of do this mashup of like, hey, this is like a really cool new technique that I know of. And like, this is a problem that maybe could be, where, I can kind of bring this technique to bear. And so I'm just going to do it. But it's often maybe not the best approach.
It's not. It's super fun. Though.
It is super fun. Yes.
Super fun, without a doubt.
But like what are some questions that kind of, anyone, any machine learning engineer kind of should ask or like think through kind of what's a kind of a good framework to use here when thinking through, hey, like, this is like the ultimate kind of problem I care about solving. How do I kind of, go about doing this in like a systematic way?
So there's, I think the best advice I got on this was from a fellow named Chris Wiggins, who was the chief data scientist of the New York Times for a few years and is a professor at Columbia. And he was a friend, and I was talking to him about this very problem. I was curious, like he joined the New York Times. This is back when I was at Cloudera. And I was asking him like, okay, how did you like get started with machine learning at the New York Times? Like, what was the problem you chose first to go after, right? And I think obviously like Chris is very sophisticated. He knows this stuff really well. And I'm sure he would have the exact same temptation to do some fun, silly thing. But instead, what he did was he figured out what the executive team was the most afraid of. And he built a model focused on that.
Interesting.
Yeah.
Okay.
And I mean, I guess like I would like to say there's anything more like sophisticated or whatever. But like, I've seen a few different patterns here that play out. I love that one the best. Like that is the one that gets you taken seriously by serious people with resources and budgets and stuff like that the fastest. What is the executive team afraid of? Build a model for that, right? Now that said, a lot of times people do opportunistic things. So like at Slack, for instance, the very first machine learning model that the SLI, Search Learning and Intelligence team built was actually like the channel leave recommender product. Some of you may or may not be like familiar with this thing, like spamming you every now and again to say, hey, you're in these channels and like, why are you here and stuff like that. And that was actually something that just kind of fell out of doing like a sort of channel recommender project. Like it was, and I think I had the same experience with like working with Capital One. Like the very first machine learning model Capital One ever built was a kind of core collaborative, like at the time we did a collaborative filtering based recommender, like, understand like what businesses did people like, shop at and stuff like that. Right. And it was, kind of non-negative matrix factorization for Slacks, but like same basic idea, right? Kind of very simple core, straightforward recommender. Because we knew we wanted to do machine learning, but we didn't quite want to know what we wanted to do it for. And so we sort of started with that as just an experimental project. And then this sort of cool, neat thing that we could launch actually kind of fell out of it, right? I mean, given the choice between those two, obviously doing the thing that scares the executives is the better path to success. But it's not to say that like the second one is a completely bad option or it can't lead to good things, because sometimes you just kind of need to start building those muscles, building that foundation, because again, that sort of core, the fundamental point of that model is to understand the relationship between users and channels. And that gets used all over the place. That gets used for search ranking, gets used for like some various other like enterprise products and stuff like that. Slack build. So it's anyway. Yeah.
Absolutely. Okay. Yeah, no, that's super super great advice. Like yeah, and kind of we try to get at some of this also like in the earlier part of the course, which is like, hey, how do you kind of yeah, sort of, starting with the prior of like there's a data set and like an evaluation metric and like kind of the within sort of the world of machine learning itself, like the goal is to do well on that data set, but then like the goal in the real world is to like actually kind of have business product impact and so on, and like how do you kind of bridge this divide.
This was a problem we had
yeah.
we had at Google, which again was much more sophisticated insofar as like the sort of predictions that like the click-through rate predictions that the machine learning model that smartass would generate were not necessarily the business outcome we were after. They were another signal to it, but there's also like the impact of the budget system, the impact of the auction ranking algorithm. Like there's a bunch of different things at play here. And it was very frustrating for the smartass team to be able to nominally build models, not nominally, like actually build models that were better at predicting CTR, but were not launchable because of the way they interacted with the other sort of systems we had in place that were like actually, making the money.
Absolutely.
And it was very much a problem that I don't know if Google ever actually managed to solve it, to be honest with you. Maybe they did, maybe they didn't. I could go probably ping some folks and find out. But like that tension is always there. And at least again, back in my day, we were not mature enough to really like separate out just pure predictive accuracy from business impact. And obviously, given the choice, business impact is going to win. So yeah.
For sure. Yeah, absolutely. Cool. Let's switch gears a little bit. Like talk a bit about the machine learning ecosystem landscape. There's a lot of activity out there.
I've lost
a lot
track.
of it is great.
Exactly.
But I think like, so what parts of the ML lifecycle do you think have become easier over the last, let's say, 3 to 4 years? Which parts remain harder, right? And broadly, like you can think of kind of data collection, training, deployment, and kind of maintenance, monitoring, observability, kind of as the 4 stages of the
pipeline. Precisely. Nihit, I you forgive me, I harp on it, but data collection is still everything. Even people who take data collection seriously kind of underestimate how important and hard it is. Like, and I lump myself into this bucket that I've like had this beaten into me many times, and I still don't. It's like if you're like renovating a home or whatever, or like you're doing some big construction project and it's like, oh, it's going to take 6 months, but it's not going to take 6 months, it's going to take a year, but it's not going to take a year, it's going to take like 2 years. Like you continually like underestimate how hard the stuff is. So I mean, data collection I think remains the great truly unsolved problem of our time. Model training has actually gotten pretty good. Like feature engineering has gotten like a lot easier. Like we've got a lot of good tools, we've got a lot of good practices here. Around training sort of pipeline stuff, I love, like selfishly, and again, this is no investments here or anything like that. I love DVC. I love data control. I actually have used it in a couple of my different projects. Weights and biases for sort of experiments and like tracking parameters and stuff like that. Great, fantastic tool. Absolutely fantastic. I think if we sort of like, if we do like kind of a conditional probability statement and say condition on the fact that you have excellent data collection, or at least adequate data collection to be doing machine learning, which again excludes like 95% of the population right there, at least. Monitoring is kind of the horrible remaining problem, right? And I think it's kind of like why we see so many like ML monitoring-ish like companies and tools out there, is because like the folks who've gone through it, like they've got the scars there. They've got the scars, exactly. And they're just like so desperate to save everyone else from the nightmare that they themselves have lived, right? So I mean, I guess like I don't know what the hard part of a lot of this stuff, right? Is it like it's an experiential good. It's hard to understand how horrible it is until you live through it. For better or worse, right? And I don't know what exactly is going to change that, but I feel good about training. I feel reasonably good about deployment. Like monitoring. It's in the same way that like people don't take data collection seriously enough, people don't take monitoring seriously enough. They think they do. They don't.
Why do you think that is? Like it's a yes, like completely agree with you that data collection and kind of monitoring are the two parts of the pipeline that still seem very seem hard, seem less fun, seem sort of less streamlined.
Yes.
Do you think kind of there's something inherent about the kind of heterogeneity of the problem space, or is it kind of more about tooling and like the maturity of tooling in these areas in your view? Or yeah, I'm curious to hear if you have any insights.
I just feel like I have kind of a bummer answer here, man, which is just like, it's just not fun. I just be perfectly honest with you, it's just not fun. Model training is fun.
Yeah.
Like running your model in production for the first time is fun.
Yeah.
That's super fun. Data collection is not fun. Monitoring isn't fun. Like having the model, degrade and drift and all the kind of problems, like figuring out like why.
Yeah.
It's not fun.
Yeah.
And to the extent that like to like people in your class, and I would say like for me as well, like to the extent that I had like a superpower or have had a good career, it's that I actually like data collection.
Yeah. Yeah.
I take it very seriously, and I spend all my time thinking about it, and like I enjoy it, and like
I
don't really care so much about model training. Like,
it
doesn't really, like, it's fine, but I'm happy to let other people do that. And so that's kind of like what I think is great about the class is like if you get into this stuff and you really get into it and you actually like intrinsically find the task interesting and fun and challenging in and of itself, that's kind of what we're missing, I guess. Basically, it doesn't seem fun. Anyway.
Yeah, absolutely. Yeah. Okay.
Sorry, I wish it was just a tooling thing. I wish it was, but it's not. It's hard and it's not fun.
Fair. Yeah. Okay. I'm thinking through, sort of some of the personal experience kind of on data collection side, and it's you're right. Like it's not fun. It's kind of, and it's very hard oftentimes to kind of know a priori kind of what kind of data to collect, right? Like it's yes, going from like when you have zero data, like okay, collecting any sort of data is will give some performance improvement, right? But then kind of as you kind of go along that kind of cycle of maturity, it becomes increasingly harder to kind of understand what data to collect. How do I think about label quality? How do I think about sort of making sure that sort of that the test set or whatever kind of have you in place of the test set like is representative of like how my world is actually changing over time and so on. And a lot of these do seem like they boil down to like data collection problems.
I mean, 100%. I mean, I guess like when I think about the stuff where I teach the stuff, it really is like we start with data collection, and I mean. I wish I could teach I wish I could teach my entire classes on data collection. Like that would be literally all we would do. But no one would sign up for that. Though,
I think.
Right?
Well,
who would do that?
I would sign up. I think a lot of folks here would sign up. Yeah.
Okay. Good. I'll talk to Amber. We'll see if we can get this one. Yeah.
Fair. Maybe like, so we do want to leave like the last kind of 10 minutes or so for audience Q&A, but maybe I'll close out with two last questions. Like how, so ML is like a fairly kind of fast moving field. There's sort of new ideas being proposed, like, every couple of weeks, there's like a new model that's out there. There's like a new company, a new startup, a new open source project. Like, how do you kind of keep up with what's going on? Are there any resources that you go to kind of for just like learning?
I don't try to keep up. It would be completely hopeless and ridiculous to keep up. I think sorry, I wish this is like my answer. Like it's sort of lame.
Fair.
Yeah, I wish. I mean, I completely agree with you. It's like an absolute fire hose and it's overwhelming and stuff like that. I don't try. Sorry.
Fair. No,
it's a really quick answer.
All right. Okay. Maybe you can squeeze one more in there. How do you, kind of, if you look at the next, say, 5 years, like how do you think the machine learning kind of life cycle, or how we build ML applications in companies, like how does that evolve? And even like, do you think that there's a difference in the types of application that would be built, say, in like the next 5 years compared to like the last 5?
That's a good question. Like, how will things kind of be different? I think clearly I don't know. It's a good question. I think we have largely settled on the architecture for a
Sure.
certain class of machine learning models, right? So I think it's like if you
Right.
combine, a CNN and a transformer. I think like Jan LeCun was tweeting about this the other day. So I guess
Right.
how do I keep up with stuff? I don't, but I do have like ambient awareness of like
Sure.
people I follow on Twitter, right?
Yeah. Yeah.
But like architecturally speaking, like whatever pre-processing system plus transformer seems like a
Yeah.
pretty solid like foundation, right?
Yeah.
Um, and so like I think that things that this will just become like sort of standardized and automated and like which
Yeah.
is sort of fantastic. Um, I guess the honest answer really kind of comes down to like how creative we are with respect to data collection. Like, in my opinion, any problem where we can sufficiently collect sufficient amount of data in digital form, with
Right.
labels, basically, is amenable to machine learning like right now.
Yeah.
And so, like the whole challenge of building a business or doing this work is really like how do you figure out a way to acquire that data these
Yeah.
days?
Yeah.
Um,
Yeah.
and I mean, I think that's sort of the unknown bit for me is like, do we get better at acquiring that data? And like, what does that look like? I like to joke that like the last sort of human field that will fall to machine learning is politics, because politics is a place where like we go out of our way not to digitize the data that actually matters for understanding like how decisions get made and stuff like that. Like it's sort
Yeah.
of very much the opposite of the point, right?
Yeah.
Um, but like, yeah, I think we've got good architectures now. It's
Yeah.
really just a question of like, can we collect the data? Can we get it together? And then I think
Right.
if you find yourself at a company that for whatever historical weird reason happens to have an amazing treasure trove of medical data,
Yeah.
amazing
Yeah.
treasure of image data, like all that kind of stuff, like really
Yeah. Yeah.
the actual modeling bit of it, I think is going to be fairly straightforward. I think.
Sure,
Yeah.
sure.
Yeah.
Yeah, absolutely. Yeah, could not agree more.
Yeah.
Cool. Maybe like the last question, and we'll open it up to audience Q&A after that. Like, just
Yep.
kind of folks, a lot of folks in the audience, to some extent me included, we're fairly early on in our kind of machine learning and data careers. Like, any advice, suggestions, insights you'd have, kind of for someone who's just getting started.
I mean, it's not too late to stop and go do something else. Mobile application development, front end engineering, really is a lot of like the whole Next.js stuff is super cool.
uh,
Um,
man,
that's maybe not the kind of advice you're looking for though, right? Like
it's well,
save
I'll leave
yourselves,
it to the
save
audience.
yourselves. It's too late for me. No, not okay.
Man, I've I tried learning some React like a couple of months ago, and
Yeah.
I can tell you, I'll much rather do data and machine learning any day.
Okay.
But
All right. All right. That's
but
fine. That's fine.
yeah, yeah.
Yeah, no, but I think I tweeted once a couple years ago that I need to get better at talking people out of a career in data and machine learning, and I still have not like mastered it. So like, given that I've failed so far to talk people out of it, and people keep wanting to do it, like, what is my real advice? I guess probably speaking, advice for getting started. I mean, I think for better or worse, to hit like the skill that we don't talk about quite so much, but it's still I think the most missing is really problem selection and formulation and stuff, and it's really
Absolutely, yeah, yeah,
like by and it's
for sure.
and so to the extent that like I recommend getting out of I don't know. I kind of love the like the sort of the various stuff economists do, the various stuff social scientists do to figure out like
Yeah,
very creative ways to like frame questions,
sure, sure.
given sort of the data they have and stuff like that, and sort of like what
Yeah,
can they like that to me is really like the hard skill.
yeah,
And so to the extent to which you can like you have an opportunity to expose yourself, even just like one thing I always like regularly recommend is baseball statistics, like sabermetrics stuff like that, like all
yeah,
the Moneyball stuff, just in terms of like how to formulate a question and like approach it in an intelligent way.
yeah.
Is just is absolutely invaluable and priceless, and is the thing that I when I hire people is like really what I'm looking for, much more so because like the technology changes, the tools
Yeah,
they always do, but
absolutely.
like
Yeah.
that sort of fundamental like
How do you test for that though? Or like how do you get, I guess, like get better
yeah
at it yourself as well? Like, is
other
it
so
partly
other
experience or?
I mean I do think so. I mean like very
Yeah,
much I think of it as kind of akin to like design
sure.
in many ways, where
Yeah,
really it's a portfolio of work that you
yeah,
need to construct.
yeah,
And I think again just it's a problem insofar as like we've gone hard after all the easy machine learning, not the easy machine learning problems, but the straightforward machine learning problems like ad
Yeah.
prediction, fraud, a lot of recommender stuff. Like we go hard
Yeah.
at this stuff. And if you want to do this stuff, it's easy to get plugged into a team
Yeah.
where all of this
Yeah.
stuff is just solved for you and you don't have to think about it. Right. But the next
Yeah.
10 years, it's not going to be about that. The next 10 years
Sure.
is going to be about how do we do all this other stuff that we have not been able to tackle yet.
Yeah. Yeah.
Yeah.
Absolutely.
That's the stuff that matters.
Awesome. Okay. Thanks so much. Yeah, let's do a few audience questions. We have quite a few in the chat. Okay, I see a question from Mohammed. When Josh started at Slack, how did he decide the tech stack? What were the considerations that he kept while making this decision?
Yeah, Mohammed, thank you. It's a great question. Oh, man. So I gave a talk about this a few years ago that you might want to, if you want to kind of go deep with me into this. It's called How to Play Well with Others, and I gave it at a machine learning conference called, or a data science conference called Rev back in 2019 in the before times. Sorry, I'm gonna give you like a way too long-winded answer to this question. Data architecture stuff is fairly faddish, and I am just as susceptible to it as anybody else. So when I joined Slack, it was 2015. The only like real large-scale data architecture I was familiar with was Google stuff. And so what I kind of went out of my way to do was replicate Google's data systems and architecture and tooling on top of AWS, since that's what Slack used. And that effectively meant using a very like Netflix style data architecture, which is to say, everything is really Parquet files in S3 with a Hive metastore, kind of keeping track of where stuff is. And we spin up and down Hadoop clusters, Presto clusters, Spark clusters, just sort of as necessary, basically, in order to do the various things we want to do on top of this Parquet data. These days, obviously, you can just pay Databricks to do this for you. You may be a Snowflake shop. At WeaveGrid, actually, we use Ray. We use kind of a weird combination for our EV detection stuff. We're using Athena to do some ETL for us, and then Ray to do like sort of more intensive and sort of like, it's a lot of time series data that's not like amenable to like relational data and stuff like that. And Ray has been shockingly great. I've generally, like, having used Spark for a number of years, I have like very complicated feelings about software that comes out of Berkeley. But like Ray has actually been very impressive, and it's been a sort of a joy to use. So I think like we are as susceptible to fads as everybody else. I would say the one thing I did, and this is back to the data collection point, in my first week as director of data engineering at Slack, I wrote a paper and got a meeting together of all the engineering leaders and said that by law, from going forward from now on, every single record that went to the data warehouse was going to have a thrift schema to go with it. Period. Full stop. That was the law forever. And everyone was like, well, that's weird, but the new director of data engineering seems super passionate about this. So, okay, sure, why not? Let's just let him do it. And that was like the single best decision I made at Slack. In fact, in many ways, it was the only good decision I made at Slack. That saved, I don't know, tens, hundreds of millions of dollars. I can't even like lost track of, and everything subsequent to that, be it data, machine learning, everything else was built on top of that solid foundation that just saved an enormous amount of time and problems and so on and so forth. So again, if I was doing this again today or starting over, I would pick probably protocol buffers these days, maybe Avro, probably not Thrift. JSON schema is actually like quite good as well. I would pick one of these things and make it the law. And then everything else is just sort of whatever, basically. Yeah. Anyway, great question though.
Awesome. I had a follow up to that, but yeah, we'll do this. After like getting through a few more audience questions. So I see a question from Ari. Like, what do you think the state of model testing, behavioral testing is beyond just basic metrics?
It's not great, Ari. Like, it's not. I mean, I guess what you're saying is like kind of like you're asking about like safety and risk and stuff like that. Yeah, it's not good. Like broadly speaking, and I really appreciate you asking the question, because it's not something we talk about enough, because it's super, super hard. Like, really. And I mean, I don't know that we have come across a better like solution at this point to some of these problems, other than having like a diverse and thoughtful and empathetic group of people around a table, like talking about like what it is we're trying to do. Um, I give you an example of like, there's a lot of stuff we can do that's like a really bad idea. um, trying to think how to say this. A lot of companies know, a lot of your cloud providers, be it Slack or Microsoft or anyone else, or Google for that matter, they can tell from their sort of usage data who is about to quit their job. They can see who's like the behavior that's sort of correlated with someone who's ready to quit their job is like pretty standard. There are even papers written about it. You can see them, right? Um, Given that, should you build a machine learning model that would tell a company, hey, so and so is about to quit their job? Is that an ethical thing to do? Well, like, no. No. um, I talked, it's kind of funny. I talked about this a bit at a few years ago. I don't remember what I called the talk. It was the first, I gave it at a conference called ML Conf. I'm gonna, I guess I'm gonna like look it up if y'all don't mind, because I can do that, because this is a, like, just go to YouTube and type in Josh Wells ML Conf. I think I'll turn this up. We'll see what it's called. Yeah, it's not a great, well-titled talk. It's Josh Wells, head of data engineering Slack, which was, ironically, it was the first talk I gave when I was no longer the head of data engineering at Slack. But it was about this problem, basically. It was about ethics and how we make these sorts of choices and stuff like that, because they are super, super, super hard. And there's no one person has the like, omniscience and like godlike wisdom to know what is good and what is not and stuff like that. And so, yeah, like I said, thoughtful people, when I was saying like study political science and stuff like that, and like study like sabermetrics in baseball and how people formulate questions, I'm also like saying study philosophy, study ethics, read like literature, like read a fucking book, basically. Think about what it's like to be a person. Like that stuff is super, super important, and is not something that we cover, generally speaking, in the kind of mechanics and technical aspects of building these systems. Yeah.
Absolutely. Yeah, I could not agree more. I so okay. There's one more question from the audience. Like, how do you know when to stop learning a new tech? Like finding the optimal point and knowing what's enough.
Yeah, precisely. I mean, I think this is such a good question. And it really is. And I think it's perfect, because I think it kind of speaks to the problem we have with data collection and ML ops in particular. In that it is 99% of the time with technology choices, do the simplest thing that could possibly work. Period, full stop. Simplest thing that could possibly work is the right choice. Database, MySQL or Postgres. These days probably Postgres, right? Do it. Don't think about it. It's great, right? Programming language, Python, Rust, Go, doesn't matter. Like simplest thing, what do you know best? Do that, right? And I think what we don't do a good job of is distinguishing kind of the class of problems for which that's actually not the right strategy. Because they are such unbelievable cans of worms, and the problems go so deep, and they are so kind of insidious, as to be merit going kind of weird. Like generally speaking, if you go down rabbit holes of like how exactly does a database work, and like what's the vector volcano model and stuff, that's not generally a good use of your time as a business. And I think the truth is, though, that like, at least again, around data collection, around ML ops, there's no such thing as going too deep in some ways. I mean, it's probably better than I do. You do ML ops stuff like professionally. Do you know everything that can go wrong? I mean, do you have a good handle on it, or is there stuff that like you don't know? I don't know.
Oh, for sure. Like, there's tons of stuff that like, that's just like, never knew about this, right?
I mean, exactly, precisely, right?
Yeah, I guess like, I mean, at least sort of, my default kind of way to go navigate this kind of problem has been like almost like this lazy learning approach of like, okay, like exactly. I'll learn it when it's needed. Like,
which is again almost always the right decision. Except
yes.
And it's funny. We had this culture at Slack as well. Slack's it was very much a place where like you do the simple thing, you do it the right way, you do it quickly. But occasionally, when you're doing some like hard stuff like this, like I mean, like we had this problem with like launching Slack Search. We were trying to do like an off-the-shelf standard sort of solar cloud replication model, we're banging our heads against the wall for a month. We can't figure out how to make this thing work. We're doing everything in the book. We're patch and master. And finally, we were just fortunate. We reached out to some friends at Apple and Salesforce, and we're just like, hey, we're trying to do this thing and it doesn't work. And they were all just like, oh yeah, no, that doesn't work.
Right.
The scale you guys were operating at, like that ingestion rate, no, that's never going to work.
Yeah.
Don't do that. And it was like a light bulb went off in our head. It just like freed us from this kind of constraint. And within, and once that was true, it was like, oh, we have to invent our own solution to this. We have to go deep here.
Right.
That was, and we could get it done super quickly, but like,
yeah,
it's kind of like one of those things is like doing the simplest thing that possibly work is almost always the right thing to do. It's a solid default.
Yeah.
But then occasionally these a few things it'll burn you. Absolutely.
Yeah, absolutely. I mean, I can definitely think of a couple of examples like this from Facebook time.
Sure. Absolutely.
Like how do you, like, and especially like in the context of like kind of content integrity problems and such, right? Like how do you kind of build a classifier for like these very specific targeted individual events, right? Like, and sort of there's just tons of them happening all over the place all the time. Sort of how do you kind of just like tame that tail was like, just like as one example. Totally. Yeah, awesome. I know we're already a few minutes over time, but thanks so much, Josh, for staying all the way till the end. And thank you everyone who attended and I see a bunch of folks are still around. Thanks so much for sharing all your insights, learnings. I see a bunch of kind of links that are shared from some of the resources that you mentioned in the chat. Like I'll make sure that we send like a summary of this to everyone who attended as well.
Cool, good stuff.
All right. Thank you so much. And Amber,
thank you, Josh. Thanks, Nahit. And thanks everybody for joining. That was a very interesting talk. And Josh, you're a very entertaining person to listen to as well. So informative and very entertaining. So thank you so much. And thanks for everybody who joined us all over the world at all different times.
Cool.
Awesome.
Bye, everybody.
Thank you.
Bye, everybody.
Bye.